Hello everyone, welcome back. It's Mr. Anderson, and today we're going to investigate from our CP/M Common Core Algebra book, section 2.1.4, and we hope to be able to answer the question, what determines a line? We're going to walk through a couple problems, we're going to talk about how to do a little bit of homework, and by the end, I hope to leave you with a little bit of info on what a slope is and how we use it, as well as what a y-intercept is and how we use it. Right here we've got a couple core problems we're going to go over, but let me just reiterate, our job is to investigate what that information is that determines a line. We do have our slope-intercept equation here, y equals mx plus b. Let me remind you that the m is the arbitrary placeholder that we use to represent slope, and then b is, of course, likewise an arbitrary placeholder. It is not a what's it called, a variable. It's a parameter that represents the y-intercept. All right, it is going to be set for you. It won't vary throughout the use of working with necessarily an equation. But how can we find the growth? We talked a little bit in prior lessons that the growth is, of course, our slope, our rate of change. And how can we find the starting value? That is our y-intercept. So let's move on here to 2-36, and I've set this up ahead of time, and hopefully you can do a little bit of reading and talking with me just to save us some time and hopefully not make these videos too long. But as we just mentioned, we do have slope-intercept form. It is a very, very common and informative form for a linear equation. We like it a lot. It gives us slope and it gives us y-intercept. But x and y are our variables, all right? And x is something specifically called, or I guess referred to as, the independent variable. We don't often get to choose what x is. It's often given to us. So x is going to be our independent variable. Y then is the dependent variable, because y depends on what x is. Often it happens where we're given an x value, and then we have to do some work with it. We have to do some evaluating, and we have to make a calculation or two that tells us what a y value is. So x is independent, y depends on x, which is why y is called the dependent variable. All right, and I kind of tried to put that in writing for you there. But they ask us about the prior work from prior sections, and they ask us to recall the tile, the growth tiles that we maybe had. Maybe you had something like this, where you had, like, this was figure 0, this was figure 1, and then et cetera, et cetera. What was x and what was y? Well, remember, x was the figure number, right? X represented that figure number, and y represented the total number of tiles. So this would have had 1 total tile in it, and this would have had 3 total tiles in it. These would have been our y's, right? And y would have depended on what x was, right? Because y wasn't the same if I was talking about figure 1 or figure 10, and so on and so forth. M and b, the slope and the intercept, those are going to be parameters. Now this might be a new word, all right? But once we have a situation defined for us, what it's telling us is that m and b don't change. So we might have a situation where we have a given slope and a given intercept, all right? So let's just say I had y equals 2x minus 1. My slope in this particular case is 2. My intercept is negative 1. If I'm working with this equation, m and b are not going to change. It might change the next time I go to work with a particular equation, but I'm not going to see it change in this case. And that's what a parameter is. Now they outline a little bit that m is also referred to as a coefficient. The slope is a coefficient because we're multiplying that by our x value, and that's what a coefficient does. And then b is, of course, a constant, right? Because that will always be the same no matter what the variable is, variable x is, okay? So in our format, y equals mx plus b, m represents slope or rate of change. We're super comfortable, likely, with that term. Rate of change is something we're going to start to explore, so we've got to get comfortable there. The b, though, represents that y-intercept or starting value. When x is 0, where are we starting? Are we starting above the x-axis? Excuse me. Are we starting below? Where on the y-intercept are we doing that? Okay? And here's what I'm going to ask you to do some thinking on and do some writing on and maybe some talking on. And you can fill this part out in your notes. But everybody look at C. C says, what effect does M have on the graph of the line? And what effect does B have? This is a pretty high order question, because what I'm asking you to do is I'm asking you to describe that change. Maybe make a comparison about that change. And if we can do that well, you're really better off than a lot of math students, right? Because this is a difficult thing. So you could talk a little bit about how the slope controls the steepness. Maybe it controls the direction. Maybe you go from positive to negative. Maybe your comments include something like that. But you could also talk about, when you're talking about the intercept, how it changes the starting value, drags it above or below the x-axis on the y-axis, drags that y-intercept above or below the x-axis. And those are we're gonna see those things start to matter as we investigate some real life problems in the coming lessons. Okay. So pause this video and maybe throw a thing or two in your notes about M and B and the impact they have on the graph of a line. But what we're going to do now is we're going to keep on keeping on. We're going to move on to number 37 or 2-37. And there's a Desmos activity here that I'm going to lead you through and I'm going to walk you through. And we're going to do some talking. You guys can pause and take notes when and wherever you need. But ladies and gents, here is the setup behind this Desmos activity. You are working at a line factory, and the line factory, of course, produces lines. And you are in this production, and you have some orders coming in. All right, a customer has ordered some lines. And the kind of thought is you can only produce a line if you have enough information to produce it. So what we're going to do is we're going to evaluate several scenarios where different information is given, and we're going to see which one yields the ability to produce a line. And this Desmos activity is great. You can click on this 2-37E tool in your textbook, and that will allow you to pull up exactly what I have right here, okay? So I click on the 237E tool. This language right here is the exact same thing in the text. And the thing I'm going to highlight, or the thing that I'm going to talk about, is if you do this part right here. If you do not have enough information to draw a line, we're going to talk about two lines that fit that order, and we're going to explain why we don't have enough information. The first line is line A. And line A, we're just given the information that it goes through the point 2,5. Now, they've set it up so I've got a couple lines to play with here, and I can drag these things. I'll drag that out of the way. They tell me a point goes through 2,5. Okay? Now look at that. Whoops, I zoomed out there. Point goes through 2,5. Done. But check this out. I can move this point wherever I want to, and I've still got that one point fixed at 2,5. So here we're in a situation where I don't have enough information to produce the exact line the customer wants, because I need another restriction. You maybe heard someone say at some point in your life, we need 2 points to make a line, and that's exactly the reason we have to kind of reject this order here. They've only given me 1 point. They've only given me 2,5. This could be anywhere. It could be a vertical line. It could be a horizontal line. It could be a line with a positive slope, etc. Let's move on to B. Line B has a slope of -3, and it goes through the origin. Now this one I like because this one is really kind of manageable. The origin, remember folks, is 0, 0. There's one starting value, right? There's my y-intercept. And then it's got a slope of -3. So it means from there, I'm going to go down 1, 2, 3, and I'm going to go over 1. Now, is that enough information to produce a line? Absolutely it is. But is there another line? And the answer here is going to be no. Because even if I went down 1, 2, 3, and over another 1, I'd still be on the exact same line. So B, we could make a line for B, and I can write that equation. I can write that A was not doable for us. B I could tie to y equals -3x plus 0, or just -3x if you like. C goes through the points -3, 2 and 3, 10. All right, I think we can do this one. -3, 2, -1, 2, 3, and then 2, up 1, 2, and then 3, 10, so over 1, 2, 3, and up all the way. I got to go up a little bit higher here, up all the way to 10. Now check it out. there we're in a situation, we didn't have the slope defined for us, but we had 2 points, and those 2 points will define that slope. So this is definitely an equation, this is definitely a line that is unique. Now look at what we can gain from graphing here. I've got an intercept, I can see that right there at 6, that's my B. Now, how far do I go from here to here, rising and running, to get that next valuable piece of information I need, the slope? Up 1, 2, 3, 4, and over 1, 2, 3. So that's going to be a rise of 4, a run of 3. That's going to be the situation. Y equals 4 over 3x plus 6. I'm going to keep moving here, folks, as we go into D. I'm just going to show you this, and then I'm going to let you explore the other ones on your own. Line D has the following table. This is kind of neat, all right? Something we get to do with Desmos how to put it, we're able to do this with the wonders of technology. I can click here to turn that table on and off, okay? And how do I make it show up? Well, if I pull this little arrow down, I can start to fill in the values. So 2, 1, 3, 3.5, 4, 6, and 5, 8.5. All right, so there we go. Now ask yourself this question. All these things showed up in purple. In order to make it a little easier, I'm going to change it to red. All right, do these points form a line? Like, could we take a ruler out and line it up and draw right through those things? And I think the answer is yeah, we definitely could. We got a slope. It looks like a up 2.5 over 1, up 2.5 over 1. So that looks like we're up 5 over 2. I've got a slope of up 5 over 2. That means I can work backwards down 1, 2, 3, 4, 5, and back this way too. So when I go back here, my slope, I'll just write this one off to the side here. Let me clean that up. Write this one off to the side. Y equals, remember we're filling in a slope and an intercept. All right, so I'm going to go here, let's see. The slope was up 5 and over 2, right? We like to write those as whole numbers. So up 5 over 2. And then what would my intercept be? Let's see, I can work just like going up 5 and over 2 to the right. I can go down 5, 1, 2, 3, 4, 5, and back to the left. Hey, look at that. My intercept is going to be right there at -4. So I can plug that in as well. And I can get rid of those to make that maybe look a little neater for you. All right. Couple more that I'm going to let you explore and let you try on your own, and I'm going to show you one more thing before this video is over that's really probably going to reiterate a couple things that you know, and this is of course that formal definition of finding the slope. All right, when finding the slope of a line, we've got 2 points here. Gloria figures out her change in y, or her rise, is -2. That's all that means. That's just a change in y. All right, rise, and the run is 3, the change in x. Explain how Gloria could find the horizontal and vertical distance of the slope triangle without graphing. Draw a sketch. Well, I'm going to cheat. I'm absolutely going to cheat. I'm going to use the graph to show you where this comes from. I put this in here. I took Gloria's 2 points and I graphed them. And check this out. Oh no, my pen's not working. Sorry. Here's my rise and here's my run in my slope triangle. That is a rise of -2. That is a run of 3. Now look at this. That's exactly what Gloria thought when she started and set out, right? So she can figure that slope out. And you've probably seen this before, but this is exactly what she could use. She could take the x1 and y1 from right here. She could take the x2 and y2 from right here, and she can plug these things in. 7 minus 5 divided by 3 minus 6. Now look at this. Up top we get 2. On the bottom we get -3. We typically, I'd take that, but we typically write this with the negative in the numerator, and that matches exactly what we found here. And of course that matches Gloria's change in y and change in x. All right. So what is the slope of that line? Ladies and gents, we just found it. It is -2/3. And then use Gloria's method without graphing to find the slope of the line that goes through these 2 points. And this is something I'm going to leave as a challenge for the viewer. So as you're watching this, give this a shot. You can use that formula. I promise it's going to check out. All right. Our review preview for this assignment is right here. And remember, in a situation where you don't have graph paper, you're welcome to just make a quick sketch in your line notebook. Thanks for watching, ladies and gentlemen. Have a great day.